At the height of the early Cold War, the sky was haunted by a titan so massive it seemed to defy the laws of gravity. This was the Convair B-36 Peacemaker, the largest mass-produced piston-engine aircraft ever built. It didn't just fly, it occupied the airspace. With a wingspan of 230 feet, longer than the distance of the Wright brothers' first flight, the B-36 was a magnesium and aluminum behemoth designed for one terrifying purpose: to carry the weight of the sun to the other side of the planet. The crew called it the Magnesium Overcast. It was powered by 6 gargantuan Pratt & Whitney radial engines, their propellers churning the air with a deafening, rhythmic thrum. But because the plane was so heavy, even those weren't enough. Later models were fitted with 4 additional turbojets, leading to the legendary aviator's mantra, 6 turning and 4 burning. When all 10 engines were engaged, the B-36 didn't just take off. It screamed, a mechanical choir of 40,000 horsepower that could be heard for miles. Inside, the B-36 was a flying fortress in the most literal sense. It was so vast that the pressurized crew compartments in the front and back were separated by an 85-foot-long, unpressurized tunnel. To get from the cockpit to the tail gunner station, crew members didn't walk. They lay flat on a wheeled trolley and pulled themselves through the narrow tube using an overhead rope, gliding over the cavernous bomb bays like workers in an industrial mine. It was a plane of superlatives and surrealism. It could carry 86,000 pounds of bombs, more than the entire weight of a fully loaded B-24 Liberator from World War II. It was built for a world where the atomic bomb was the only currency that mattered, designed to fly from the United States to Europe and back without ever touching the ground. But even this giant wasn't radical enough for the atomic age. As the 1950s dawned, the Air Force began to wonder, what if the plane didn't just carry the bomb? What if the plane became the reactor? As the Cold War escalated into a fever dream of atomic ambition, the B-36 was chosen for a mission that sounded like science fiction: Project ANP, Aircraft Nuclear Propulsion. The Air Force didn't just want a plane that could carry nukes. They wanted a plane that was powered by them, a flying Crusader that could stay airborne for months at a time, circling the globe like a vengeful moon. To test this, they took a massive B-36H and transformed it into the NB-36H, later nicknamed the Crusader. This wasn't just a modification, it was a structural rebirth. In the aft bomb bay, engineers installed a 1-megawatt, air-cooled nuclear reactor. It sat there, a ticking heart of fission, humming with a terrifying, invisible energy. But the real engineering miracle wasn't the reactor itself, it was how they kept the humans alive. The standard cockpit of the B-36 was scrapped and replaced with a massive, 12-ton lead and rubber-lined vault. The crew, the pilot, co-pilot, flight engineer, and 2 nuclear engineers, didn't just step into the plane, they were sealed into a tomb of protection. The windshield was made of leaded glass nearly a foot thick. Every bulkhead was reinforced with layers of lead and water-filled tanks to absorb stray neutrons. For the men inside, the world outside was filtered through a heavy, yellow tint. They were the most shielded humans on Earth, yet they were sitting mere dozens of feet away from a live, unshielded reactor. The lead engineer on the project was a man of cold, hard mathematics who understood that they were playing a game of Russian roulette with physics. He knew that the crew's safety depended entirely on the integrity of that 12-ton capsule. If a single seal failed, or if the water tanks leaked, the crew wouldn't just be flying a plane, they would be sitting in a microwave. The Crusader was painted with a massive, glowing orange radiation symbol on its tail, a warning to anyone who saw it. It was accompanied on every flight by a chase plane filled with armed paratroopers. Their orders were grim. If the NB-36H went down, they were to jump immediately, surround the crash site, and shoot anyone who tried to approach it, not to keep secrets, but to keep people away from the lethal, radioactive fallout that would vaporize the surrounding landscape. The B-36 had evolved from its Peacemaker into the Crusader, a mechanical knight carrying a holy, glowing fire that could either save the world or poison it forever. The NB-36H Crusader took to the skies over the American Southwest 47 times between 1955 and 1957. To the casual observer on the ground in New Mexico or Texas, it appeared to be just another massive B-36, but the orange radiation symbol on its tail told a much more radical story. This was the era of the nuclear dream, where scientists believed that fission could solve every human problem, including the pesky limitation of fuel. The ultimate goal was Perpetual Flight, a bomber that could take off and stay in the stratosphere for weeks, or even months, orbiting the Soviet Union like a permanent, predatory satellite. During these test flights, the 1-megawatt reactor was lowered into the active position. It wasn't actually turning the propellers yet. The plane still relied on its traditional 6-turning, 4-burning engines, but the reactor was running at full power. It was a live-fire exercise in the most dangerous environment imaginable. The engineers were obsessed with mapping the flux. They needed to know if the 12-ton lead vault was enough to stop the neutron rain that poured off the reactor during flight. Inside the cockpit, the crew watched Geiger counters and dosimeters with a fixation that bordered on the religious. Every click of the instrument was a reminder that they were separated from an agonizing death by nothing but layers of rubber, water, and lead. The flights were conducted with a level of paranoia that would be unthinkable today. The Crusader never flew a direct route. It followed a radioactive corridor over sparsely populated deserts. Following close behind was a C-119 transport plane packed with a hot area recovery team. These men were trained to handle a broken arrow, the loss of a nuclear weapon, but this was worse. This was a flying Chernobyl. If the B-36 suffered a catastrophic engine failure, there was no simple way to jettison the reactor. It was bolted to the airframe. A crash would mean a molten radioactive core plunging into the earth at 300 miles per hour, followed by a plume of fission products that the wind would carry for hundreds of miles. The sheer audacity of the mission was breathtaking. On one flight, the reactor was run for several hours at high altitude to see how the thin air affected cooling. As the reactor heated up, the air passing through the bomb bay became ionized, creating an eerie, invisible trail of radiation behind the plane. The crew sat in their yellow-tinted silence, feeling the hum of the 6 radials and the 4 jets, knowing that beneath their feet, a controlled star was burning. They were the pioneers of an age that never truly arrived, a world where the sky was meant to be filled with nuclear-powered giants, and the only limit to human reach was the endurance of the men inside the lead line box. The inherent terror of the B-36H wasn't found in a mechanical failure that actually happened, but in the mathematical certainty of what would happen if the Crusader ever fell out of the sky. This was the crisis point that haunted every briefing at Convair and the Pentagon. The aircraft was a flying paradox. It was designed to be the ultimate deterrent, yet it was a greater threat to the American citizens it flew over than to the enemies it was meant to intimidate. If a standard B-36 crashed, you had a conventional fire and a pile of magnesium wreckage. If the Crusader crashed, you had a broken arrow of unprecedented proportions. The 35,000-pound reactor was not encased in a containment building like a power plant on the ground. It was held in place by standard aviation mounts. In a high-impact crash, the reactor core would almost certainly rupture. If the cooling systems failed, which they would the moment the airframe disintegrated, the core would undergo a meltdown in the middle of a burning wreckage pile. The heat from the burning aviation fuel would act as a thermal lift, carrying vaporized radioactive isotopes, cesium-137, strontium-90, and iodine-131, high into the atmosphere. The military's secret projections for a worst-case scenario were harrowing. Depending on the wind speed and direction, a crash near a population center like Fort Worth or Albuquerque could have necessitated the permanent evacuation of thousands of square miles. We aren't talking about a temporary cleanup. We are talking about creating a red zone that would remain lethal for generations. The paratroopers following in the chase plane weren't there to save the flight crew. They were there to enforce a cordon of death. Their orders were to set up a perimeter and prevent anyone from entering the plume, effectively presiding over a temporary exclusion zone until specialized teams in lead-shielded tanks could arrive to entomb the wreckage. This was the flying Chernobyl reality. The crew in their 12-ton lead vault might actually survive the initial impact due to the sheer structural reinforcement of their capsule, only to find themselves trapped in a lead coffin at the center of a radioactive inferno, waiting for a rescue team that couldn't get near them without melting their own protective gear. The realization began to sink in at the highest levels of the Department of Defense. They were flying a dirty bomb over their own backyard every Tuesday. The strategic value of Perpetual Flight was being weighed against the potential of accidentally vaporizing a piece of the American Midwest. The Crusader was no longer just a plane, it was a 150-ton liability with a nuclear heartbeat, and the clock was ticking on how long luck would remain on their side. The death of the nuclear-powered aircraft didn't come from a mid-air explosion or a reactor meltdown, it came from the cold, hard logic of the space age. By the late 1950s, the nuclear dream was being eclipsed by a new, more efficient terror: the Intercontinental Ballistic Missile, ICBM. While the Air Force was pouring millions into the B-36H to solve the problem of flight endurance, scientists like Wernher von Braun were proving that you didn't need a pilot to stay airborne for weeks to hit a target across the globe. You just needed a rocket that could leave the atmosphere and come back down in 30 minutes. In 1961, President John F. Kennedy officially pulled the plug on the aircraft nuclear propulsion program. The math was no longer in the Crusader's favor. An ICBM was cheaper, faster, and, crucially, didn't involve flying a live reactor over the heads of the American public every afternoon. The flying Chernobyl was grounded forever. The B-36H, the only aircraft to ever fly with an operational nuclear reactor, was stripped of its radioactive heart. The reactor was shipped off to a laboratory for further testing, and the massive, lead-lined airframe was towed to the boneyard at Davis-Monthan Air Force Base in Arizona. The final end of the Crusader was as unceremonious as its life was spectacular. Because the airframe itself had become activated, mildly radioactive, from the years of neutron bombardment, it couldn't simply be melted down for scrap. Workers wearing dosimeters and protective suits had to carefully dismantle the giant. Eventually, the pride of Convair, the 150-ton behemoth with a 12-ton lead vault, was cut into pieces and buried in a specialized trench, covered by layers of earth to silence its atomic echoes forever. The resolution of the B-36 story marked the end of an era of atomic hubris. It was the moment the United States realized that just because you could put a reactor in something, didn't mean you should. The project proved that the engineering was possible, but the sociology was impossible. We could build the lead vault, we could map the flux, and we could fly the 6-turning, 4-burning giant into the sun, but we could never solve the problem of the crash. The sky was no longer the place for reactors. As the last pieces of the B-36H were buried in the desert sand, the nuclear bomber transitioned from a weapon of the future to a ghost of a path not taken. It remains the closest humanity ever came to a flying Chernobyl, a mechanical titan that proved some fires are too hot to be carried into the clouds. The legacy of the B-36H Crusader isn't found in the aircraft that followed it, but in the terrifying realization of what total war almost looked like. It stands as the ultimate monument to the atomic hubris of the 1950s, a decade where American engineers believed that if you threw enough lead and enough money at a problem, you could conquer even the laws of nature. The B-36 wasn't just a plane, it was a transition point. It was the moment the military realized that the human element was the weakest link in the nuclear chain. You could shield a pilot with 12 tons of lead, but you could never shield the world from the pilot's potential mistakes. Today, the Crusader exists only in grainy, declassified photographs and top-secret files that smell of ozone and old paper. But its DNA lives on in the most unexpected places. The data gathered from the B-36H's lead-line vault directly informed the shielding used in the early days of the NASA space program. The mapping of the flux helped scientists understand how to protect astronauts from cosmic radiation during the Apollo missions. In a strange twist of fate, the plane designed to deliver death ended up providing the blueprints for how humans could survive the journey to the stars. Furthermore, the B-36 story remains a chilling warning in the age of modern drones and automated warfare. It was the last time we truly considered putting a live reactor in the hands of a human being in the sky. It proved that some technologies are too heavy for the planet, not in terms of physical weight, but in terms of moral and environmental risk. The B-36H remains the only time a human being has ever sat in a chair, looked out a yellow-tinted window, and driven a nuclear meltdown across the horizon. In the lore of aviation, the B-36 is remembered as the Peacemaker, but the nuclear variant is remembered as a flying Chernobyl. It is a mechanical ghost story that reminds us of a time when we were willing to gamble the safety of entire states for the sake of an extra hour of flight time. It is a reminder that the most dangerous weapon isn't the bomb itself, but the ambition of those who try to tame it. As we look toward the future of fusion and high-tech energy, The buried remains of the Crusader serve as a silent, radioactive sentinel, warning us that some fires are meant to stay on the ground.